Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine a world where AI models don't need teachers anymore, no labeled data, no human feedback, just learning from themselves. Today's story is inspired by a paper titled When Models Judge Themselves, Unsupervised Self-Evolution for Multimodal Reasoning by Zhengxian Wu Kai Shi. And it flips a core assumption in AI training on its head. So here's the problem. Modern multimodal models, those that reason over images and text, are powerful, but they rely heavily on expensive supervision. Think annotated reasoning steps or teacher models trained on curated preference data. That's not scalable. Now, some methods try to remove supervision using majority voting, generate multiple answers, pick the most common one. But here's the catch. According to the example, the most frequent answer can actually be wrong. So instead of learning truth, the model learns its own mistakes. That's the core tension. Now here's the core idea, and it's elegant. Instead of trusting one answer, or even the majority, this framework lets the model play two roles, an actor and a judge. The actor generates multiple reasoning paths, like brainstorming. Then the judge steps in and scores each reasoning trajectory based on correctness, reasoning quality, and visual grounding. But, and this is key, the judge doesn't override everything. It only modulates the actor's self-consistency signal. Think of it like a coach, not a dictator. You can see this pipeline clearly: actor, multiple answers, judge scoring, calibrated rewards, optimization. Then comes the really clever part. Instead of picking a winner, they treat all trajectories as a distribution. Using something called group relative policy optimization, the model doesn't collapse to one answer. It gradually shifts probability toward better reasoning paths, like adjusting weights, not flipping a switch. Now let's talk implementation. Step 1. Sample multiple trajectories per input. They use around 8 rollouts per question. Step 2. Compute self-consistency scores. Basically, how often each answer appears. Step 3. Apply judge modulation. A bounded function adjusts scores, so no single trajectory dominates too early. Step 4. Convert scores into relative advantages within a group. And finally, optimize using GRPO. What's interesting is they never use ground truth labels. Everything is generated, evaluated, and refined internally. Training runs on standard setups like 8 GPUs, ARM optimizer, moderate learning rate, and yet performance improves consistently. Now the results on multiple benchmarks like MathVision and Dynamath, the model improves significantly. For example, from 25.0% to 30.9% accuracy on MathVision. That's a big jump without any labeled data. You can see it even competes with supervised methods. And here's something subtle but important. The training dynamics shown on page 7 charts maintain higher entropy, meaning the model keeps exploring. It doesn't collapse into one repetitive answer pattern. That's a huge win for stability. But there are pitfalls. First, the judge is frozen. So if its evaluation ability is limited, the whole system inherits that ceiling. Second, if judge scores are used directly without calibration, training becomes unstable, dominated by a few trajectories. Practical tip: always keep the judge as a modulator, not the final authority. And preserve relative comparisons, not absolute scores. That's what prevents collapse. So what's the big takeaway? This paper shows models don't just need better data, they need better ways to learn from themselves. And this actor-judge loop might be a glimpse into fully self-evolving AI systems. The next question is, what happens when the judge learns to? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.